Okay, we're going to work a little bit more now, continue to practice about how to determine proportionality. So, two different approaches. The first one on the left is very straightforward. They're giving you 9 tables, and you're trying to figure out in different ways if there is a constant proportionality. If there is a number, I am regularly multiplying the x by to get the y. And so I'm looking, and you can see in the first one, I'm times 3. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. In the second one, I do not have a constant proportionality. I am not multiplying by the same number every time. And so if I look at the first two, I am multiplying by 2. And remember, we talked about this in class, that you have to check more than the first two. I mean, you can't be lazy. You have to go through the whole thing and make sure that you have a constant, which means every single time. And you can see in that one you don't. And in the third one, you can see that you are multiplying by 5. Every time you are multiplying by 5, 1 times 5 is 5, 2 times 5 is 10, and so forth and so on. So there you go. This table has a constant of proportionality. This table does also, and this one does not. Okay, going to the second set of 3 tables. In this one, changed a little bit. You needed to find some missing values. And so once I can see that I am multiplying 1 times 13, I know that 13 is my constant of proportionality. I'm multiplying by 13. And so each of those x's gets multiplied by 13, which is where I get that 26. In the second one, I can see that 1 is times 26. And so then I would take the x and I would multiply, in each case, the x by 26. In the last one, they don't give you the 1. So they're saying, okay, so if 8 is 120, what is 1? And you would find out that that would be 15. And so then I'm going to multiply all the x's by 15. In the last set, they give you an equation. So in each set of 3, they're doing it just a little bit different. In this, I want you to notice that this is the constant of proportionality. That is the number I'm multiplying by. And you see that they have you restate it down here. They want to make sure that you're connecting the fact that the constant of proportionality is written as a number you are multiplying times the x. That is critical. Okay, then so you just go through the table and you multiply whatever by whatever that constant is, and then you can fill out the table. You're using the equation, remembering that the number you are multiplying the x by is the constant of proportionality. Okay, let's go to the second one. This has got I like this because it has really a variety of things, but sometimes the writing pieces are a little bit confusing for people. So in A, let's look in A. And so to be clear, the ratio is Johnny weighs 312 pounds on Jupiter and weighs 120 on Earth. So there's my ratio, 312 to 120. Marco weighs, 520 pounds to 200 pounds on Earth, okay? And Sally weighs 208 to 80. And if it is proportional, that means that their weight on another planet, on Jupiter, is proportional to their weight on Earth. And I can find that by finding the decimal equivalent. And the decimal equivalent is, in each case, when I divide them, 2.6. So you'll notice that I have circled, yes, it is proportional, because in each case, I'm multiplying the pounds on Earth by 2.6 to get the pounds on Jupiter. And I could have also written that as a table. I could have said, Earth 120 multiplied by 2.6 is 312. 200 by 2.6 is 520. And 80 times 2.6 is 208. So I could have done it in a table too and figured out what I was multiplying. And this would be Earth, and this would be Jupiter. So I could have done it either way. But in each case, I'm trying to find, am I multiplying Earth by the same amount to get Jupiter? And I am. So that is proportional. Okay, let's go to card B. I'm also looking for, what am I multiplying by? I'm multiplying this by 1.5. I'm multiplying this by 1.5. I'm multiplying this by 1.5. And 1.5 and 1.5. So it is proportional. And I can't see the 0, 0 if it's going through 0, 0. But if every x is multiplied by the same constant, then that is proportional. I'm going to go to card C. Notice that this is a straight line. Okay, so it is linear, and it does go through 0, 0. So it's linear, and it goes through 0, 0. And if I look at the points, look at what they are. 1, 30. 2, 60. 3, 90. 4, 120. So the constant of proportionality there is 30. Okay, D is very straightforward. It's a table, and you can see that in each case, I'm multiplying the cupcakes by 3 minutes. So it's 1 cupcake for each 3 minutes. So to be clear, that constant of proportionality is 3, because that's what I'm multiplying by. In card E, I'm looking for a constant. I can see very clearly that it is linear, but it does not go through 0, 0. So automatically, looking at that graph, I know, absolutely not. It is not proportional. It does not go through 0, 0. It cannot have a constant of proportionality. And so you can see that I've circled no. On the last one, card F, I'm doing the same thing I did in card A. I'm saying the company charges 70 cents for every 14 minutes. Okay, and you can see on the side here that I have determined that per minute it is 5 cents. In the second company, for every 21 minutes, it's $2.10. Well, that is different. That is 10 cents a minute. And the last one is 5 cents, but they do not all match. They would all need to be 5 cents a minute, which they are not. So there is not a constant of proportionality, and so I circled no, because there is no constant of proportionality. I am multiplying by a different number in the Transcontinental Connectors phone company than I am in Jibber Jabber or S Mobile. So it cannot be proportional. Okay, if you have questions, make sure you see me and get that straightened out.